Hello everyone, welcome back. In this example, we're looking at a grouped frequency distribution table, or a GFDT, for the salaries of employees at a small business. That's the data entered into this table below. And using this data, we want to find the best estimate for the mean, the median, and the mode when it comes to these employees' salaries. And so we have these 6 different intervals for salary ranges of all these different employees at this small company, but we don't know how the frequency of these salaries are distributed within each range. And that's where it starts to get a little bit mucky, right? In this first interval from 0 to about $30,000, we don't know how those 5 employees in that range have their salaries distributed. Maybe some of them are making like $10,000, $5,000. Maybe they're all making close to $29,000. We don't know. That kind of information is lost in this analysis. So when we're trying to make an estimate using a grouped frequency distribution table like this, what we basically do is kind of reorder or recategorize the data by, instead of working with these salary ranges, we find one value to represent that entire salary range. So what value do we choose as the representative for this entire range between 0 and just about 30,000? Well, we use that midpoint or average value between the endpoints of each interval. So we're going to create a new table here where, instead of having a range of intervals, for each of these intervals, we're going to be taking that kind of middle point or average salary value for each interval. So let me go ahead and create that table for us, and then we'll be able to move forward with our analysis. All right, so here I have this new table formatted and filled in for us. So that middle point salary in that first interval from 0 to $29,999 was $14,999.5. So now we're going to pretend like all 5 of those employees had that kind of middle or average salary for that interval, and then we repeat that for all the other intervals in our data set. And by doing this, we really kind of translated and approximated our ordinal data set into an index data set. And now that allows us to quantify it better and find things like the mean and the median, where we couldn't really do that before. All right, so if we want to calculate the mean or the average salary with this reformatted version of our data set, we just have to remember how to do that. We have to add up all these salary midpoints and then divide by the total number of points in our data set, or by the total number of employees. So we have 5 employees making $14,999.5 on average. So it'll be 5 times that value of $14,999.5. Then we have to add to this the value we get by taking the sum of 20 employees with a salary of $44,999.5, or by adding 20 times 4,999.5 to our current sum. And so you probably don't want to hear me list this all out, so I'm going to go ahead and write that, and then we'll jump ahead. All right, so in our calculation so far, I just have the frequency of each of our new data values multiplied by that data value. So this is like finding like the sum of all these salaries for all the employees, but then we still have to divide this by the total number of employees in our data set here. And let's see, well, I guess we could have had a cumulative frequency kind of column to help us do this. But if we add up the total frequency or total number of employees, it looks like we should get 119 in total. And so we have to divide this sum by 119. So if you're entering this all into your calculator, be very, very careful, right? This is like the numerator of our fraction, and then we have to divide that by 119. So make sure you put an extra set of parentheses or brackets around that running sum in our numerator. Otherwise, only that last term will get divided by 119, and that'll mess up our calculation. And hopefully that'll be pretty obvious when you look at the number you're getting. It should look way too big. But if we do enter this all into our calculator correctly, then our best estimate for the mean, or our grouped frequency distribution table mean, is going to end up being $87,352.40. So we don't know the individual salaries of all these employees, but the best guess we can make using this method is that the average employee at this small business has a salary of about $87,352.40. All right, so next we want to make our best estimate, or our GFDT estimate, for the median and the mode. Remember, to find our median or kind of middle data value point, we have to look at the n+1/2 data value when they're all written in order from least to greatest. And remember, our total number of data points or employees here was 119. So which data value are we looking at that represents the median or the best estimate for the median? Well, it's going to be 120 over 2, which is the 60th employee in order from smallest to greatest. So which kind of range or midpoint would correspond to the 60th employee? Well, the first 5 are in that first interval or have an average salary of about $15,000. 25 gets us here, and we're trying to get up to 60. So somewhere in this third interval from 60 to 89, or just about 90,000, will lie the median employee's salary. And so we're going to say that that median employee salary, or the best estimate for it, is going to be $74,999.50. And so last thing we have to find is the mode, or the best estimate for the mode for these salaries of employees. And we're not listing ranges for the mode, just like how we didn't list ranges for the median or the mean. Instead, we're going to say the mode is that salary midpoint that shows up most frequently, which is still corresponding to that interval that shows up most frequently when we're measuring the employees' salaries. And so let's see, this interval had the most with 45 employees in it, and the midpoint for that interval was 74,999.5. So just like the median, the mode is also going to be $74,999.5. So now we've seen how to take a grouped frequency distribution table, convert it into a more normal type of frequency distribution table that allows us to do our quantitative analysis on it, so we could find these good estimates for the mean, the median, and the mode.